that it's leptokurtotic, or whether it's negative, that is evidence to suggest that it's platykurtotic. Either way, it will be evidence to suggest that it is not mesokurtotic, or it is not this, the kurtosis is not 0. And don't forget, we've transformed our kurtosis back to 0. Okay. So we're going to have to calculate our critical value C1 and our critical value C2, in which case both of these particular critical values has to have half of the significance, half of the 0.05. Alpha over 2 is going to be in the right hand tail, so that's 0.025 is going to be in here, sorry, in the left hand tail, and alpha over 2, which is equal to 0.025 of the area, needs to be in the right hand tail. And we've done this in our previous video, but let me just do it again. So what critical value has 0.025 of the area to the right? Okay, well, what does that mean? That means there's 0.025 of the area under the curve to the right of the critical value, which means to the left of the critical value there must be 0.9750 of the area to the left. The cumulative area, that is, so the total area under the curve up to this critical value on the left hand side of it must be 0.9750. And we've got a set of tables that allow us to calculate critical values associated with cumulative areas. Okay, so we've got a set of Z tables, and actually we've already done this, so actually what I'm looking for is 0.9750. Actually, that's on the row 1.90, and it's under the column 0.06. These are my Z scores here and here. When I add these two things here together, I get a Z is equal to 1.96. So that's my critical value. So let's just rehash this here again. Let's just do this once more. Let's just draw our curve again. So we have our curve, looks something like this. Oh, it's centered on 0. Our critical value is C1 and our critical value is C2. The area in here is 0.025 and the area over here is 0.025. This critical value over here is 1.96. That's 1.96. This one over here, through symmetry, is minus 1.96. Okay. So what these are representing is that if our test statistic is further away to the right than this value, or further away to the left than this value, that's evidence to suggest that our distribution in fact doesn't have 0 kurtosis. Okay. Now our test statistic that we've calculated just there previously is Z of k is minus 0.4678. Now minus 0.4678, this Z of k, okay, is actually in here. Okay, it's in here somewhere. Okay, it's minus 0.4678. We're not far enough away from this 0 position for it to be significantly different to it. Okay, and hence we're not in the rejection regions, so we fail to reject. So our decision that we're going to make here, our decision, which is our 5th step in any hypothesis test, our decision is clearly our test statistic, which is Z, it's Z of k. Okay, Z of k is not less than, actually the absolute value of it. Okay, it's a two-tailed test, so I'm going to throw away the signs. The absolute value is not bigger than my critical value. What I mean by that is that 0.4678, okay, it's not bigger than my critical value, is not bigger than 1.96, and as such, we fail to reject H0 at the 5% level of significance. Okay, of significance. Okay, and continue. Okay, without any evidence. Okay, without any evidence. Okay, so without any evidence, yeah, to suggest that the distribution, okay, that the sample, okay, was selected from, okay, is different to the skewness or the skew or the kurtosis, yeah, okay, of a normal distribution, okay. distribution. Okay. So there's no evidence to suggest that we're lepto or that we're platy, and so we're left with we're left with no evidence, so we cannot reject the null hypothesis. Okay, guys. Once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. And thank you for watching. Okay, bye bye.